We're Team ZATTA, a team of 6 MBT students. We're going to introduce our smart alarm. Our smart alarm has two modes, an alarm mode and a clock mode. At a set time, the first buzzer starts ringing, and you can stop it using a button. Then the second buzzer will start working automatically, and you cannot stop it unless you get off your bed and pass through the door. This is where the infrared sensor is placed. Finally, after the two buzzers stop ringing, the valve starts pouring water coffee. Thank you.
طيب دلوقتي احنا الكلوك شغاله hours minutes seconds. دلوقتي هنسويتش للالارم مود علشان نسيت الالارم اللي احنا عايزين نحطه. فدلوقتي هيبقى الارم minute 1 و hour 0. بس دلوقتي هنستنى بقى لغايه ما هنا يوصل 1 minute علشان الالارم يشتغل. احنا دلوقتي الالارم مود قلنا عملنا 1 minute. اوكي بس لما نوصل مع بعض المفروض لما توصل 1 minute بازر 1 هيشتغل كده. هنشوف بقى هيحصل ايه بعدها. دلوقتي فاضل 3 seconds. طيب دلوقتي بازر 1 اشتغل. دلوقتي هنشفت البازر 2 فكده بازر 1 قفل، بازر 2 اشتغل. دلوقتي بقى هنعدي ايدينا على الانفراريد علشان نقفل التو بازرز والميه تبدا تشتغل. دلوقتي هشيل ايدي على الانفراريد فالبازر يشتغل تاني. عاملين بقى الزرار هنا بيقون واوف البازرز عشان الميه المفروض تفضل شغاله بقى. بس فكده
Hello everyone. Now I'm gonna talk about the coding behind all that hardware. First off, we have the clock generator module. What the clock generator module is, it returns a clock as an output. It returns the clock as an output, and then it goes into the process. First of all, it sees if the reset's actually true. It resets the counters and the clock. If not, we continue by counting, incrementing the clock one by one until it reaches the max out 25, and then it returns it for 0. What it does is it gives the clock to the other modules and the registers. Here, there's the 60 counter module. The 60 counter module, it takes the clock and the reset as inputs, and what it returns is low and highs. The low is the first digit and the high is the second digit of the seconds, the minutes, and the hours. So what it does is every negative edge of the clock or the reset, if the positive edge of the clock, it begins by starting everything with 0 if the reset is true. Else, if it's not true, we increment. We check if the seconds, if the low of the seconds is 9, we increment the high. For example, if we count from 1, 2, 3, 4, 5, 6 until 9, and then we increment the 9, we increment the high and set the low with 0, as we can see here. Then we check. Sorry. Yes. Yeah. Then we check if it's maxed out. If the high reaches 5 and the low reaches 9, and we check if it reaches 59, we increment the minutes, and so on we go. We increment to 5, 9, and then we put the high and the low for 0, and then we increment the low of the minutes, and so we do the same for the minutes. We do the same. If it's 9, we increment the high, and if not, and then we put the low with 0 until it reaches 49. We do the same. If it reaches 59, if it reaches 59, we increment the hours until the hours reach 23. At this moment, we actually set everything 0 and that's how the clock works. Thank you.
Welcome. I will going to talk about the two main modules in process, the PR and the 60-second count. First, the PR, or setting the alarm. This module, its function is to set the alarm we want. As we have an input switch, it is an alarm, set alarm, and the increment, bottom increment of hours and the bottom increment of minutes. First, we check if the alarm is on, so the mode of alarm is on, we can use the increment and increment of minutes. How do we increment? We check if the digits, the high and low of hours is not reached yet 23, then we can increment. And the minutes, if it's not 59, then we can increment. If they reach these two values, they are set to 0. And these values are saved then to be our alarm. Then we switch to the 60-second count. It's the main module where the calling of all the modules happens. It contains two main points, the calling and the switch of modes. We have the clock mode and the alarm mode. If alarm is on, then it's alarm mode. If alarm is off, then is the clock mode, the normal clock pace. And this module contains all the inputs and outputs needed in our project, the clock and the reset and the buttons of increment and the buttons and the button of off and the IR, the infrared, and the output of all buzzers and the water valve. This happens here. And also we have the calling of all the 7-segment decoders to switch to be displayed on the 7-segment on the FPGA. Thank you.
I'm going to talk about two modules that we have, 7-segment decoder and compare module. First I'm going to talk about 7-segment decoder. Simply it takes a number and outputs a segment. This module works as follows. If the input number is 0, it outputs 7 bits like this one. 0, it's going to be a high signal, 1 high signal, 2 high signal, 3, 4, and 5, and 6 is not going to be displayed because it's going to be off because we don't want to display it, so we get 0, the number 0. How does it work? It simply works with cases. If the number is 1, 2, 3, 4, and each one has a case, which is 9 cases. Next, I'm going to talk about the compare module. The compare module takes a lot of inputs. It's considered one of the main modules that we have. The input that the compare module takes, that is the clock. Off is a switch, button 1, and stored minutes high, so minute low because the minute is high and low. It's divided in 2 points, high and low. Clock minutes high, clock minutes low. Stored hours high, stored hours low, and clock hours low, clock hours high. That's the input. The output is buzzer 1, buzzer 2, and water. Simply how does it work? We have a switch that's called off. Simply off, this terminates all of the buzzers and make the water valve opens. The logic goes as follows. If the buzzer 1 is on, we're gonna check if button 1 is off. If button 1 is on, we close buzzer 1. And then we check if IR is crossed or someone closed the IR. The buzzer 2 also will turn off. And if we turned off the buzzer 1 and buzzer 2, the water valve will open and we will have water.
This breadboard have 2 buzzers and 1 infrared sensor. All 3 elements are connected to a common ground node. This ground node have a connection with the Altera port on its ground pin on it. For the first buzzer, we have a VCC wire where we connect it with a pin on the Altera board. We give it a 0 or a 1 so it can indicate whether the buzzer can buzz or stop. Same as the buzzer number 2, it's VCC also here, as we can put a 0 or a 1 so it can buzz or stop. For the infrared sensor, it's a VCC. It's connected with the pin in the Altera board where it gives the 5 volt, as it can work probably with its full power. Here we have a wire with an infrared sensor. That's it. It's an input sensor wire where we connect it with the Altera board, so we can indicate whether there is an object crossing the infrared sensor or not. Also with a 0 and 1. For here, the ground node, and it's VCC. As I said, with a 5 volt pin. Also, there is an 5 volt pin also connected here for the water pump, but I can't show it to you right now as we share it with another group. That's it for the breadboard, but for the Altera board we have 3 switches, one for setting the alarm, one for stopping the alarm, one for swapping between the clock and the alarm, so we can see what time is it and when the clock will start. And we have the 3 buttons. Works on the Altera board. First button resets the alarm, and the second one it increments minutes for the alarm, and this third button increments hours for the alarm, and that's it.